Okay, so this is a bit of a short one. This is on using implicit differentiation with partial derivatives. So let's take an example of an equation that's multivariate. So let's go x cubed plus y cubed plus z cubed plus 6xyz is equal to 1. And we're going to envision this as z being a function of x and y. So we're going to find the two partial derivatives. We're going to find the partial derivative of z with respect to x and the partial derivative of z with respect to y. So we're going to take this implicitly first with respect to x. So the first term is going to give me 3x squared, right? The second term is just a constant, so that goes away, and so is the third term because those aren't moving with x. And then the last one, z is not a constant. Z is a function of x, so that's going to give me 3z squared, and then we take dz dx there, right? This is a function of both x and z, so we have to use the we call it the product rule here. So we're going to look at this as 6y and then yz, right? So let's take let's see, the derivative of the first times the second is 6yz, and then the first times the derivative of the second is going to give me 6xy d partial z over partial x, right? And then the derivative of 1 just comes out as 0. Alright, so we can kind of join this up together. The two things with the partial are that and that, so that's 3z squared plus 6xy times dz dx, right? Moving these two to the other side is negative 3x squared minus 6yz. A little bit of division gives me dz dx is negative 3x squared minus 6yz all over 3z squared plus 6xy. That's a plus. There we go. Alright, so if I pull the negative sign out from the top and divide everything through by 3, I should get negative x squared plus 2yz over z squared plus 2xy. Okay, so that's the partial with respect to x. Now we're going to start the game over, and we're going to take the partial with respect to y. So when we take respect to y, that term goes out, leaves me with 3y squared plus 3z squared dz dy, all partials, plus, okay, so let's look at what's going on here. We get the y comes out, so that's going to be 6xz, and then we get 6xy dz dy, right? Okay, so that's my product rule, and 0. So let's bring these two out front again. 3z squared plus 6xy. And we're going to multiply that by the partial, dz dy. And then we bring these two to the other side. Negative 3y squared minus 6xz. I need to make some corrections up above because I recognize that when this came over, that should be negative, right? So that means that this is negative, and then when I pull the negative out, that goes to positive. So this in the end is correct as long as I view that x as outside, right? So, okay, sorry about that. Had to make little corrections there, but I think we got it. All right, let's look at this again. So we brought these two over. So now we just do some division here, right? dz dy should be this, negative 3y squared minus 6xz over 3z squared plus 6xy. Pull the negative outside out front, divide everything by 3. Gives me y squared minus 2xz over z squared plus 2xy. Right, and that one is the partial with respect to y. This one here is the partial with respect to x. So there's the partial with respect to x, there's the partial with respect to y. There's the two partials, both done by implicit differentiation. So lots of stuff going on there, but it's the same, pretty much the same method that you would use in a single variate situation, but now you're doing partials with multivariate equations. All right, so implicit differentiation.